Okay, Ryan Muhammad, homework number 3. Um, all the CSV files are uploaded. Uh, but I was a little bit confused just by the instructions, but just seemed to go with my gut and just do everything like we've been doing. Um, but yeah, I definitely looked at the other homework and I tried to create my propositions before seeing the output of the query or even coding the query, just trying to put together like the concepts and what how everything's working together. But just to start off, I'm just gonna go through these pretty quickly just because there's a lot of content and I don't want to make an hour video. So yeah, I guess I'll just start going through these notebooks and um, talking about the gist of things. So what this query does, it's a scalar subquery, so it just first is subquery, it kind of, so just to get this out the way, so the execution of these kind of subqueries, it goes from this statement and then this statement, right? So this will obviously run before any of this stuff, right? And this kind of acts as input to this guy right here, right? So what this does, it just gives me back one single value, meaning that scalar value. So I'm just checking, okay, give me that maximum order ID, right? And I'm just checking, okay, does this match it, right? This is a subquery, right? This is just one value. So moving on, this is more of the same. Not yet. Well, this I could use equals, but moving on, just as a better example, I guess. Uh, So this one, this is just gonna give me back all employees with the last name starting with D. Um, but right here, that's gonna give me multiple values back, so it's not a scalar subquery, it's a multi-valued subquery. Alright, so I can't use the equals operator here. Um, um, actually, uh, I'm actually pointing to the wrong spot. I can't use the equals operator right here. I have to use the in operator, right? Uh, uh, because this is going to give me multiple values and it's going to execute this before any of this, right? And then this serves as input to here, right? So I'm just checking if I'm in any of that list of values. So moving on more of the same, just using an inner join for this instead, right? Just to get those orders shared, um, the combination of order and employee based on the employee ID. So it just gives me back orders from that employee ID. US customers, so this inner query gives me all US customers, right? And then I just go through my orders table, right? And I check if that order exists in whatever I got back from this multi-valued subquery. Moving on, I'm just gonna go through this a little bit faster. Maximum order ID. So for each, we'll see more of this in chapter 5. But this just runs the same kind of query, but this time we have a little bit of a correlation between the outer query and the inner query, where I'm using those aliases, right? So yeah, that's kind of what's going on here. This just gives me back the maximum order ID for each of those customers, right? So rather than a single customer, right, I can run this for every customer, right? Maximum uh order ID of customer 85. I think this explains the next one a little bit further, right? Yeah, this one was definitely a challenging one. Should I give it my best shot? This is a scary one. Okay, so basically what this does, probably best to start at the inner query. Um, so it just totals up the quantities. So using this table right here, order values, right? It just totals up all the quantities of all the orders placed by that that customer, right? So so let's say this customer one, he may have ordered like, I can't really round this too well in my head, but let's say like 180 or so, like that. That's probably right, right? Like around 180 things. So it would just sum up all of these for me, right? So what I'm doing is I'm kind of I'm just going through each each one of these individual orders. And I'm seeing how much that individual order's quantity kind of accounts for that customer's total quantity of purchases and stuff like that. Um, so that yeah, so that's I was getting a little bit confused by the naming here. I was like, isn't this the total quantity? But yeah, this is the sum of the total quantities. Um, so yeah, how much this individual total quantity accounts for that customer's total quantity right here. Um, this should be an aggregate, uh, shouldn't it? Okay, but yeah, that's pretty much all this guy right here does, even though he's pretty scary. Uh, Customers from Spain who place an order, customers from Spain who didn't place an order, so that didn't proposition. Uh, so that then implies that not, but this uses not exists. It just goes through each one. I'm just checking. Okay, does there exist a record of you in orders, right? And if you don't, um, then you did not place an order. So first, this outer query, well, not really. This inner query gets orders placed by customers, and then this outer query gets customers from Spain, and it just checks. Okay, does does a record of this customer ever being in orders exist? And if it doesn't, I'll return you. And only this customer from Spain did not order. But how am I doing on timing? Okay, not bad. Uh, yeah. So moving on to the exercises. Um, So yeah, this utilized scalar subquery. So all these propositions came directly from the questions. But here I'm just getting back all orders placed on the pretty much most recent date found in the order table. So I just get the most recent date by using the scalar subquery, and then I go through the order table and I just find all matching dates, all orders with the matching date, right? And I just order it up. So customers that did not place orders on or after, so this kind of, once I saw did not, I kind of thought not in, right? So first I found customers who did place orders on or after that date, and I just checked, okay, does this employee exist? Or not exist, but is this employee part of this list, if you will? Uh, Countries where there are no customers but no employees. So this one was a little bit tricky to break up in my head, but I figured just to kind of split it up like this. So first find all the employees countries, right? And then just go through each of the customers countries and just return it if it's not in any of the employees countries. So it just kind of filters out those employees countries. Moving on, for each customer is all borders placed on customer's last day activity. So this one, yeah, so this one is kind of like that for each thing, but we'll see more for each stuff here once again. But yeah, so here I'm just finding the maximum order date. So I'm creating a correlation between the outer query and the inner query, right? So hence the aliasing, right? So what I'm doing is pretty much oh yeah, I'm just finding the maximum order date for that customer, and then I'm just gonna return that order. Um, but yeah, so this is each customer's most recent order basically, right? Wrong scroll bar. Uh, Customers who placed orders in 2015 but not 2016. So this was kind of okay. So yeah, I split it up into two subqueries. You can see those right here: 2015 orders, 2016 order customers, and here I'm just using them in an exist statement. So what's basically going on here is I'm going through each customer and I'm saying, okay, does there exist a record of you placing an order in 2015? And does there not exist a record of you placing an order in 2016? And if so, I'll return this back to you. Right, so that's kind of how I split it up. Right. Um, I also tried not in. I think not in would have worked for this as well. Um, but here the difference between in and exist. So that's well, along these more along the line of these ending queries. So the difference between in and exist is so basically, yeah, I think I was kind of hinting at this throughout this. In kind of runs. I'll try to put it away so no cheating. In pretty much runs before all of the other queries, right? The outer query, it'll run before the outer query, right? So imagine I had an in right here. This statement would run first, and then whatever I return back, it kind of acts as input to this guy out here, right? Um, and I'm just checking, okay, does this current uh, row or item exist inside of whatever was returned, right? So it's returning still multiple values, right? Where exists instead returns a Boolean value. So it's more so kind of like checking a condition, right? And basically, it's kind of a bit more efficient because it's only going to run, it's only a Boolean operation, right? And it's going to run once for every row that's returned by this outer query, right? So if I return back 9, like employees, this little kind of inner Boolean check, if you will, is going to run once for each of those. So that's kind of the difference um, between those guys right there. Um, but I think that's enough of that. Hopefully I did well on timing that. But I'm just going to pause and make sure those other files don't crash anything. But here we go. Okay, so this one I'm going to really try to go through as quick as I can just because it took a good solid couple minutes to get open there. But so chapter 5, this was about table expressions. But I really try to implement them in both of these guys right here. So I'm just gonna quickly go through the proposition. There were a lot of propositions, so I'm just gonna try to go topic by topic, I guess. So this just derives a table, right? So instead of using like an actual table in my from clause, I'm deriving a table by using a subquery, right? Like I can use a subquery inside of a where clause, but it either has to be a scalar subquery or a multi-valued subquery to make sense in a where clause, right? But in a from clause, I can use it to derive a whole table, right? So that's kind of what's going on here. So here I'm kind of deriving a table of USA customers, right? And I'm just getting everything from it, right? So a big thing that comes with these, I've been noticing that comes with these table expressions is readability and just really like the highest level of being able to dictate what a query does instantly. But moving on, probably shouldn't be going 1 to 2 under this condition, but derives a table for each year's number of customers. So yeah, once again, trying to do these propositions before the code. But what my inner query does is it pretty much derives a table of each customer's order years, right? So it goes through each of these their orders, and it just kind of creates a table of them alongside of every year that they've ordered, right? So for each customer, if they've ordered in 2014, 2015, 2016, there'd be a table of 3 times however many customers there are. But yeah, so that's what years each customer has ordered, right? And then I'm just using that, and I'm being a little bit more kind of thoughtful about how this looks in terms of readability with that inline aliasing, right? So in this inner clause or inner subquery, right, I'm creating this alias order year, right? But because this runs before anything else, I can use this alias and this alias as well outside in my top level query, right? My outer level query, right? So I'm just getting each order year, and I'm counting okay all the distinct customers in that year, right? So I get the number of customers in each year, right? Basically, right? So that's why I need to use that group by, because I'm using the aggregate function, right? Where that year is constant, right? So I'm moving on. I should probably move on a little bit further along. Okay, column aliasing. So this is more along the same lines, but this is external column aliasing. I didn't really make much use of this. I thought the other one was a little bit cleaner in my head, but here we're just doing it outside here, right? Outside of the subquery, right? So it's same as above. So yearly count of customers handled by employee 3. Okay, so this utilizes a variable, or in this case, an argument. Right? All I have to do is change that to get the customers handled by that employee, right? But the inner query derives a table of the order years for each customer, right? Where their employee was this variable, right? And then here, just in terms of the outer query, just a little bit more readability. Select order year of distinct customers as number of customers, right? So more readable. Just kind of push the pace here. Okay, this one was a doozy. Let's give it a shot. Um, so number of current customers, previous customers, and growth of customers for each year. So this kind of makes use of, yeah, pretty much returning or deriving that table, right? But here, whatever we derive, we're aliasing, right? So, and then we could use two of these guys in a join statement, right? So what this first query does right here, this subquery gets the number of current customers for each year. What this query does right here gets the number of customers for the previous year, right? So the way it does this, right? So let's think about the execution here. So obviously this is gonna run first, and a left outer join that's just gonna give me this and everything that matches it in my kind of clause right here uh, back into a table, right? But it's gonna keep my nulls, right? And I'll explain why that's important in a second. But what this guy does right here, the way it gets the previous year is it pretty much goes through all the years in the order table, and it gives me back the year. It's pretty much the same table, it just named previous, right? But what I'm returning back is from this previous table is only the order years that kind of are um, before the matching current order year, right? So for 2014, right, in the current table, right, there is no record that would satisfy this in the previous table, right? The previous table, that's the derived previous table, right? So that's why it's probably good to have this left inner join. If I use the inner join, I wouldn't even get this row back, right? So that's why that left outer join comes in handy right here. Um, let's keep going. So this is table expressions and inline column aliasing. It says a yearly count of customers. So more along the same lines as the other examples. But I really like how this looks. I think I was trying to use this a lot. But just a different kind of syntax. I feel like this kind of really presents those aliases early. So once you get down here, it's a little bit more separated in terms of thinking, for me at least. External column aliasing, so just using that with the table expression. I didn't really make too much use of that. So same thing with that table expression, with the argument. But here, this one really made me excited. The multiple CTs, just using multiple of them. So here you can see with this alias of the derived table, I'm using this guy in this one, and he can use these aliases, and he can create more aliases that can get derived further down, right? So here I get a really readable statement, right? Just select all the number of customers exceeding, so just for each order year, right, give me back the number of customers, and only give me back the where those number of customers exceed 70. So years where the number of customers exceeds 70, right? So multiple references. So this is yeah, along the same lines as that other statement, but definitely helps with the readability for sure. So the first thing I'm doing is getting a yearly count, right, of customers, right? Instantly more readable, at least to me. And then I'm using that inside of this query, right, to just return me back just the number of current number of customers, right? But I'm joining it with the same CTE, right? Just alias differently, right? So I'm using multiple references to it, right? So it's pretty much the same thing, right? So what that other code did in so many lines, where I'm doing essentially the same thing, right? This just does just like this by using the multiple aliasing fact. And I do expect a little crash right here coming in to change my cursor. Okay, I guess it stopped. Okay, how much time do I have? Okay, let's push the pace on this one. So I'm gonna try to skim through to whatever other concept I see there and just try to get through the exercises. I'm just gonna try to quickly show that I did them. Yeah, the recursive one was a challenge. Definitely still have to think about that. So the views, so yeah, for these ones I use my Docker. That's why my Docker's still open. Should probably close it just to get better performance, but just in case I have to run a query, I'll keep it open. But yeah, these views were interesting to me, and I ran into an issue. Oh yeah, so those views, the views combined with the table expressions really seemed cool to me. Um, some really kind of like abstraction, if you will, but not really, I guess. Uh, So yeah, this is just going through all those things. I think I'll kind of save this. I think all the things that we went through here will come in handy in the exercises. Okay, I'll give schema binding a shot at explaining really quickly, because it was interesting going through the problems. So what schema binding is whenever I create a view, right? So a view is just kind of uh, so it's kind of like my query saved, basically the result of my query saved, right? So it's basically just a table, like a virtual table. And I create that virtual table using a query, right? And I save it as a view, right? But what if I want to go and insert something into that view, right? And um, or what if I want to go and well, that I think that's a very different problem. What if I want to go and remove something from that view, or well, not really in that order. What if I want to go and remove something from the schema that view uses, right? So what if that view was used, right? We created it based on some table, right? So in this case, we created something based on the customer table, right? USA customers is obviously based on the entire customers table, right? But then in the customers table, I want to go ahead and remove the address, right? I can't really do that because, well, technically, if without schema binding, I can do that, and that would be a problem because I have a view that's reliant on it, right? But with schema binding, right, I can kind of clearly state, okay, this view is dependent on customers, right, in this case. And then now my kind of code knows to kind of alert me, okay, am I trying to change something that my view is dependent on? Check option. Okay, so like this is more so along the lines of satisfying a condition. So in this USA customers, the way I even get this view is using my query, right? And my query is just for USA customers, right? But here I'm trying to explicitly put in um, a British or United Kingdom customer, right? Uh, uh, and that's why when I kind of try to go back and see it, right, I can't really see it, and it kind of like sneaks its way into there and into the underlying data table, right? So with check options, right, I can check to make sure, okay, is what I'm putting into this view uh, valid, right? Should it even be able to enter there before it sneaks its way into my database? So this is function. Function is really fun. That one was really fun. Uh, just the syntax of that. So the way a function works, right, it just returns back a table, right? So I'm just stating that I return back a table, and the way I do that is after my return clause, I just put this, not really a subquery, or yeah, you can call it a subquery, but a query nonetheless that returns back a table, right? So one of the biggest things I took from this chapter, that select statements uh, return back tables. Um, Return table customer one. Yeah, so one. Okay, and then cross apply down here. I think there is a problem. Okay, so it's kind of like cross join, but it's more so like running this code for each and every one of the outer queries rows. But more on that later. Hopefully I ran through that pretty quickly. But just going through the exercises. So the first one, so the problem here obviously is aliasing, that parsing issue. I think we talked about this chapter 1. This statement is actually last here, the select statement, this runs first, then this. So this guy has no idea what end of year is spelled like this, right? Because this statement happens after, so that's the problem. So obviously we could just put this guy down here, but that would be not very readable, right? So a better solution would be for inline aliasing. So use a subquery to derive a table, right? And then in the outer query, we can use that alias, right? Using that inline aliasing of the column, right? So this just gives me back the end of year for each order. Maximum order date for each employee, right? So I think I used a table expression for this. Yeah, so I just derive a table of maximum orders for every employee. And yeah, so that's pretty much it. And then I just use it for some high level statements outside. Right, select employee ID, maximum order date from max order. Right, so from that derived table. Just using a alias there. Order table combined with max order date for each employee. So that utilizes the above query. So here, yeah, once again I have this derived table max order, and what this query then does with that derived table, it joins it with the orders table, right? But it's an inner join, so I'm only gonna kind of join it to get the order dates associated with that employee ID. Or not, I'm not really explaining that right. So I just want the matching employee ID record, right? And I want the order that I want the order that matches this maximum order, right? Basically, right? Hopefully that makes sense. So for employee ID, right, this would be there. I'm returning this back, right? Only because it matches the maximum order date, right? Hopefully I put that the right way. Okay, ranks each order based on order date, order ID. So this was, yeah, immediately when I heard ranks, dot row number, I had to dig through my notes a little bit, but here I'm just ordering over the order date and order ID pretty much, and I'm still making use of that table expression. Moving on, I'm gonna try to really finish this off here. Yes, so it's already 27 minutes. I'm just gonna show most of the code. If anything sticks out, I'll explain it. But just to spare us all, keep it short and sweet. View containing. So this was just me experimenting with the view. Pretty much just deriving a table and then using that as my view. Right. Here's my solutions. My cleanup. Here's the last guy. So I think I'll explain this one. So here I had to make a function that finds me the top products, right? So it takes in a parameter of the supplier ID and then the number of products, right? I'm just using that in this query, right, to form a table of all the products sold by that supplier ID, and I'm just ordering those by the unit price, and then I only return back the top n, right? So based on that argument, right? So here this does run as expected. Gives me back the top two selling products of supplier 5, right? But here I use cross apply because I want to run this function for each row from this outer query, right? So this outer query, this outer query gives me back the supplier ID, right, or the suppliers, right? For each of those suppliers, I'm just finding the top two products, right? By using that cross apply, right? Because using this cross apply, I could just pair it alongside with this derived table from using that. Well, in this case, a return table, right? So yeah, hopefully I didn't run through that too quickly or stumble too much at the end. But yeah, fun as always, and thanks a lot.